If you're taking Calculus 1, you're going to be talking a lot about limits. But what actually are limits? Limits describe the behavior of a function in which x approaches a specific value but never actually reaches it. Let's suppose we had a function y equals f of x, and we can see that there is a hole at x equals 1. But let's say we wanted to find out what the function will output if we get as close to 1 as possible, but never actually reaching it. So let's take the limit. We can approach 1 from either the left side or the right side. If we approach 1 from the left side, we can see that the function will approach 4. If we approach 1 from the right side, we can also see that the function will approach 4. Therefore, we can say that the limit as x approaches 1 of the function f of x is equal to 4. Let's try evaluating limits algebraically. Let's try evaluating this limit. So here we have the function 3x squared minus 5x plus 1, and we want to know the value in which x approaches 4. Here we can do this a couple ways. Let's try plugging in a number that is close to 4, but not actually 4. Let's call this function f of x, and let's plug in f of 4.01. And this is going to be equal to approximately 29.83. So let's try a number closer to 4. How about f of 4.001? And this is going to be equal to square. And this will be equal to 29.018, on and on. And so as we approach 4, we can see that f of x will approach 29. So we can say that the limit is equal to 29. It's also important to note that with this limit, we can also directly plug in 4 because nothing will be undefined. This is called evaluating the limit by direct substitution. And so if we do this, it will be equal to 29. Same answer. Let's now evaluate the limit as x approaches 2 of the rational function x squared plus 1 over x plus 3. Again, here we can do direct substitution because if we plug in 2, nothing will be undefined. And this will be equal to 5 over 5 or 1. So the limit as x approaches 2 of x squared plus 1 over x squared over x plus 3 is equal to 1. Let's evaluate the limit as x approaches 3 of the rational function x squared minus 9 over x minus 3. Let's try direct substitution again. Here we get 0 over 0, which is indeterminate. So we can't use direct substitution, so we're going to have to try something else. We can notice that the numerator can be factored. It's a difference of squares. So let's factor. It will be x minus 3 times x plus 3 all over x minus 3. And we can notice that the numerator and the denominator will cancel out each factor. And so now we're left with the limit as x approaches 3 of x plus 3. And so since nothing will be undefined now, we can now use direct substitution. So the limit as x approaches 3 of x squared minus 9 over x minus 3 is equal to 6. Let's evaluate this limit. As x approaches 9 of square root of x minus 3 all over x minus 9. Let's try direct substitution. Again, we get 0 over 0. Therefore, we cannot use direct substitution. Whenever we see a square root, it's always a good idea to multiply the top and the bottom by the conjugate. So let's do that. We're going to multiply by square root of x plus 3. If we expand the numerator, we will get, it's a difference of squares, so it'll be x squared minus 9. Oh, sorry, not x squared. It will be x minus 9 all over x minus 9 times the square root of x plus 3. And as we can see, the factor of x minus 9 will cancel out. And we're left with the limit as x approaches 9 of the square root of x plus 3. And over here, we can now use direct substitution. And so this is going to equal the square root of 9 plus 3, which is equal to 3 plus 3, which is equal to 6. Therefore, the limit as x approaches 9 of the square root of x minus 3 all over x minus 9 is equal to 6. Let's try one last one. Here we have the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. Here, again, we see a square root, so it's a good idea to multiply the top and the bottom by the conjugate. The conjugate in this case is the square root of x plus 1 plus 1. And that will be multiplied by over the top and the bottom. And again, this is a difference of squares, a squared minus b squared. And so it will simplify to x plus 1 minus 1 all over x times the square root of x plus 1 plus 1. Let's bring it up here. What we can notice on the top of the fraction is that the 1 and the minus 1 will cancel. And so we're left with x over x times the square root of x plus 1 plus 1. And we can also notice that the x and the x will cancel out. And so we're left with the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And here we can use direct substitution. So this will equal 1 over the square root of 0 plus 1 plus 1, and this will be simply equal to 1/2. And that is our final answer.